this is just a short video to have a quick recap over angles. Now, the angles that we're going to focus on just now are angles in a circle. Now, there are 3 rules that you need to know. You need to be able to use them independently of each other, so they might only be asking them one at a time. Or it's more common, they might ask all 3 in a combination, all in the same question. So, the first thing that we need to know is that if a triangle is formed by a chord, now a chord is a line that goes from one point of a circle to another without passing through the center. Okay, if it was to pass through the center, then that would be a diameter. So chords don't pass through the center. And if that, we can make a triangle by using 2 radii, and that triangle there will always be an isosceles. Now, it's always an isosceles because those 2 radii are obviously the same length. Okay, so I can always form an isosceles triangle there. Now, because that's isosceles, I know that the angle here and here are always going to be the same. So if we were to look at that as what a question might be, for example, if I want to find what A and B are, well, I know that that's a radius, so it must be an isosceles triangle. So to work out what A and B are, well, the angles in a triangle must add up to 180. So I have 87 degrees taken up. Now, whatever's left is going to be evenly shared between A and B. So I'm going to have my 180 take away 87. So I'm going to have 93 degrees left to split between them. So each one, because it's split evenly, must be half of that. So half of 90 is going to be 45. Half of 3 is going to be 1.5, so it'll be 46.5 degrees. And B is going to be 46.5 degrees. Now, I've got one for you to try on the right-hand side, okay? So at each point, okay, you're spotting that isosceles triangle. That's very often the trickiest part here. I'm subtracting that 87 from 180 purely because I know it's a triangle that's going to add up, the 3 sides add up to 180, or the 3 angles, sorry, add up to 180, and then I'm halving it at the end there. So can you try on the one on the right-hand side? Now, if you're not enough time, pause it, and then press play to see how you get on. Now for yours, they're the 2 lengths that are the same, okay? Now, I've given you a different angle here. So I've actually given you 44 degrees here, which is the same as A, because it's those 2 angles of your isosceles triangle that are the same. So I can read off straight away that A is 44 degrees. Now, to work out B, if I know what 2 of the angles are, I need to add the 2 together. So 44 add 44 equals 88. And now whatever's left to make 180, that must be what B is. Or I can do 180, take away the 88 degrees, which is going to give me 92 degrees. So B must be 92 degrees. Now, they might add different elements to this. Okay, so they might ask you to build it up. Now, this is where the easiest way to do these questions is to just fill in the values that you know. So if I know that this is 105, well, I know that adding on B makes it a straight line because there is my straight line. Now, 135 plus what makes 180 because it's a straight line? Well, that must be 45 degrees. Now, there's my isosceles triangle, so from O to B and from O to A, which means that A must be 45 degrees. Those 2 together make 90, so what's left must be 90 degrees. Now again, back to my basic angle facts. I have what's called vertically opposite angles. So the 90 degrees is going to be the same on that side as well, so they're the same angle. So the one on the left will be 90, and then the same scale because I've got another isosceles triangle on that side there with those 2. So D must be 45 and C must be 45 as well. Now, whilst it might look slightly messier, I'd highly recommend that you draw a sketch of this and you annotate it. So you put the angles in there. If you're ever writing it down, you have to refer to the angle specifically. Now, it's easy if it's called C, D, A, and B, but it might have trickier names, and you have to get the name correct. it is far more likely that you'll get marks by just annotating it on the graph. Anything you write on the graph can be marked. Okay, so just put in the angles where you see them on your graph or on your little diagram. Now, one for you to try, again, working in a slightly different direction. So pause the video, take as long as you need, and then press play. So first one, I can read off straight away that A is 50 degrees. I add those two together, that's going to get 100 degrees, so what's left must be 80. Vertically opposite angles, so across from there must be 80 as well. Again, there's 100 degrees left for that triangle, so split it between D and C, because again, I know I've got two radii there, so it's isosceles. And then the last one to find B, well, that's a straight line with C and B, so that must be 180. So B must be 130 degrees. Now, that's the first angle property, so spotting that isosceles triangle. Now, the second one, okay, now this one can be a little bit wordier, okay? If you want to read it through fully, then please press pause and do so. If not, I'm going to keep talking through it. Now, take a diameter, and from each point, whether it be on the left or the right, we draw two lines and meet somewhere on the circumference. Now, wherever that meets on the circumference is always a right angled triangle, and the right angle is always at the point on that circumference. So there's my right angle there. Now, this is true no matter where it is. So let's say I want to meet here. So I draw a line from there, I draw a line from there. That will be right angled. And let's pick a different color. I've used green, so what was going to show up here? Yeah, let's use blue. Let's take this point here. So dotted line, dotted line. That would be a right angle. No matter where it is, that is always going to be a right angle triangle. Now, it's sometimes called as an angle in a semicircle, and the reason why it's called that, because there isn't any semicircle there, is very often we kind of cut off the bottom there. So we make, because we half that bit at the bottom, it obviously makes the top half a semicircle, and that's why it's often referred to as angles in a semicircle. But essentially, the gist of it here is you need a diameter, joining up at one point on the circumference of two other lines, that is always a right angled triangle at the circumference. So what you might get is something like this. And again, same as before, use your graph to annotate. You're spotting different things here. So already I can see from up above, there's a diameter, there's two lines joining. So it must be a right angle triangle here. These two angles together must add to make 90. Now, there's other things going on here. I can see that's the radius, there's a chord. So I've got an isosceles triangle there. So I can see that that angle B must be the same as that angle there. But that's not the only one. I can see another isosceles triangle, radius, radius, chord. So the angle here must be the same as the angle there. So there's lots of different angle properties going on in this one question. So let's start to fill in a few values that we can work out. So I know that here's 28. I know that it is an isosceles triangle, so this part here must be 28 degrees also. And I will make that slightly bigger, just so you can see it. Now, to figure out A, I know that I need to add the two 28s together and take it away from 180. 28 plus 28 is going to give me 56. And if I do 180, take away 56, I'm going to get 124. So A must be 124 degrees. Now there's a couple of different ways you can get B. The easiest way is to remember that angle in a semicircle, that right angle there. So 28 and B must add to make 90. So to work out what B is, I do 90, take away 28 to find out what's left, and that's going to come out as 62 degrees. So B must be 62 degrees. And that's all the angles that they're asking me for. So that's all I need to put in. One on the right-hand side for you guys to try. Press pause to take as long as you need to work through it, then press play to see how you get on. So again, a couple of different things going on here. I can see that I've got an isosceles triangle in here, so there's an isosceles triangle. So that one must be 40. I add them together. So I add 40 and 40 together, so A must be 100 degrees. Now, again, a couple of different ways we can work out B. However, I know that that's a right-angled triangle in there. So using my diameter and my two other sides. So this must be 50. And again, I've got another isosceles triangle in here. There's another isosceles triangle. So B must be 50 as well. Now, last one. This is our third circle angle rule, and then we'll look at trying to put a few of these together. Now, the last one's to do with what's called a tangent. Now, a tangent is a line that meets a circle in one place and one place only. Now, that tangent is perpendicular, so it forms a right angle with a radius that meets it where it's touching that circle. Okay, so essentially, if you've ever got a radius and a tangent, they're always going to meet at a right angle, so 90 degrees. Now, the sort of question you can get is something like this. And again, a couple of different things going on here. So there's a radius, there's a tangent. Okay, so that's going to be 90 degrees. But I've also got an isosceles triangle in there. So already we're starting to see them mix together. So using the fact that I know it's an isosceles triangle, that one must be 62. Now, if they're both 62, if I add those together, I get 124 degrees. So whatever's left, which is 56 degrees, well, that must be in that top corner there. Now, I know that OAC, so that's this angle here, is 90 degrees, and I already know that 62 is taken up, so whatever's left must be this angle in there. So 90 take away 62 is going to be 28. So that's 28 degrees there. Now I know I need to find out what OAC, so I have a triangle here, 1, 2, and 3, so there's a triangle there. So the three angles must add up to make 180. Now, this is where, and I'm going to use the highlighter just to show you this bit, because there's different ways you can always do this. So I've got a triangle there, okay? Now, there are three angles that are going to add to make 180. So there's going to be this angle here, there's going to be this big angle here, and this third angle here. Now, the three of those must add to make 160. So I've got 56 degrees from the top, add, now I know my 62 and 28 make 90, add, and it's whatever that other angle is that will add to make 180. So if I add those together, I'm going to get 146, and then do 180, take away 146 to find out what's left, and I must have, apologies, I need to move that one along one. It's not going to move for me. So it must be 34 degrees that's left. And so I'm going to have 34 degrees in there. As I said, there are other ways to do this. Okay, there is more than one way to answer these angles questions, and more often than not, the ones that you'll see in tests or the ones that you'll see in textbooks are the same. There's more than one way to answer this. Pause the video, take as long as you need to attempt this, and then we can work through the one on the board. Now, angle ACB. The easiest way to go straight to this one, angle here, that 90-degree angle there, and the angle at ACB add to make 180 degrees because it's a triangle. 1, 2, 3 sides. I can ignore that line A to B. It's there just to distract. So I know that that's 90. So if I add those together, 54 add 90 is 144. So whatever's left must equal whatever this angle is here at C, and which is going to be 36 degrees. Now, they will put a lot of these together. So I've taken a past paper one, so you will see this when you're going through your past papers and practicing some more of these. Now, they will mix lots of different things together. So see, first of all, pause the video, see if you can spot as many of these as you can. So let's start with the first one. So we're looking for isosceles triangle. Radius, radius, chord. There's one isosceles triangle. Radius, radius, chord. there's a second isosceles triangle. Diameter, two lines coming from either side meeting at the circumference. That's 90 degrees. Radius, tangent. So on both sides of that, that must be 90 degrees as well. Okay, so there's so many different things going on here that you can start to build in all the angles that you need to know. Now, one thing I would recommend, whatever it's asking you to calculate, just ignore it, especially to begin with. Okay, just fill in the values you know. Don't get too caught up in trying to get to some endpoint because you'll get stuck on how to get there. Just fill in the values and you'll naturally start working towards it. Now, 58 degrees there, radius, tangent, that must be 90 degrees. So 58 is already being taken up. So what do you need to add on to make 90? That must be 32. Now I knew that radius, radius, chord. There's an isosceles triangle. I pop 32 back in. So this one must be 32 as well. Now I can work out the missing angle here because I know what two angles are in the triangle. So they're adding together to get me 64. So what's left must be 116. And just to double check, 180 minus 64 would be 116. Perfect. Now, I know that this angle and the 116, because it's a straight line here, must add to make 180. So the bit that's left must be 64. Now again, this is where there's a couple different ways. So again, I know that this is an isosceles triangle. So I could do 180, take away 64, and half each angle. So 180 take away 64 is 116. Half that is going to be 58. Now, remember I said that there are different ways to do this. Diameter, two sides meeting at the circumference. Remember, this makes a right angle. So 32 and 58, well, that makes sense. That makes 90. Okay, so that, another way I could have got the 58, instead of going round by the 64 and the 58, I could have said, well, there's a right angle there, and filled it in from that point of view. Now, again, I know, looking at this 58 degrees down there, see, they must add together to get 180 degrees. So 180 take away 58 is going to give me 122 degrees. Now, again, I know radius tangent, so that must be 90 degrees. So 58 and that angle there must add to make 90. So that will be 58 and, apologies, I just realized it's taken out this one in the bottom left here. So sorry, 90 take away 58 is going to give me 32 degrees. And I've just realized it's taken off my other angle at C. So that was 180 take away 58. So that will be 122 degrees. Apologies. And then the last bit, again, there are so many triangles you can form here, but I've got a triangle there. So I could add 122 and 32, take that away from 180. So I'm going to use that one. So 122 add 32 is going to give me 154. And then 180 take away 154 is going to give me 26 degrees. So again, I always annotate on the graph. There's 26 degrees. Now there are different ways that you could have done that final step. There are so many triangles here. So there's a triangle there. So you could have used 64, 90 to get 26. There is one final triangle which I'll draw on going the full way up. Okay, so you could have used 32, the 90 and the 32 together to find that triangle there. There are so many different parts and so many different ways that you can actually build up these answers. So again, I've got another one on the board here. So if you want to, pause it, see how many angles and semicircles or 90-degree right angles, tangents with radiuses, or your isosceles triangles you can find. So again, ignore what you're going towards, okay, because you will eventually work there. Now 77 and this angle here must add together to make 90 because there's a radius and a tangent. So what's left must be 13 degrees. Now, radius, radius, chord. That must be an isosceles triangle. So up here must be 13 degrees. Now, I know diameter meeting at a point on the circumference, that must be right angled. So here must be 90. Now again, I had a triangle there, so the three angles must add up to make 180. I've got 64 and 90, which will be 154. To work out what's left is I take that away from 180, which is going to be 26 degrees. So that'll be 26 in there. Now, the angle I'm finding is BDF. So BDF, let's pick a nicer color than that. BDF is BDF. So it's that full angle in there. So the angle BDF is going to be 13 add 26, and 13 add 26 is 39 degrees. So have a work through, especially some of the ones that look more like circles. Slightly different angle properties will come in with different shapes. But I hope you found this video useful.